A 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 calcium hydroxide. What was the concentration of hydrochloric acid in the original solution? So after reading the question, the first thing you're going to want to do is go back through it and find important information that can help you visualize what's happening in this exchange. So in this case, we know that we have 75 milliliters of hydrochloric acid. So going back off of previous knowledge, we know that 1,000 milliliters is equal to 1 liter. So we can go from 75 milliliters to 0.075 liters in our hydrochloric acid solution. But we're going to have to leave molarity as a question mark because we had an unknown concentration originally. Moving on to the 27.3 milliliters of calcium hydroxide and the 0.157 molarity for it, we can draw the beaker over here of our calcium hydroxide and change our 27.3 milliliters to 0.0273 liters with a molarity of 0.157. And we know we're going to add it based off of our balanced equation, which is written above right here, in order to get our final solution. So going back to more previous knowledge, we know that molarity equals moles divided by liters. So if we go from the calcium hydroxide, we knew that we had 0.0273 liters and a molarity of 0.157. Based off of this information, we can find the moles of calcium hydroxide, which after multiplying it out, you get 0.0042861 moles. So taking the moles of calcium hydroxide that we have, we can convert it to the amount of moles of hydrochloric acid in our original balanced equation. So if we take the number and we put it here, and we take however many moles it takes to convert an equal amount over, which here is 1. We do 1 mole of calcium hydroxide in the bottom, and we do 2 moles of hydrochloric acid because that's the balanced equation at the top again. So multiplying the moles of calcium hydroxide times the moles of hydrochloric acid, we get 0.0085722 moles of hydrochloric acid in the original equation. Now going back to the original question, it asked what the concentration of hydrochloric acid was in the original solution, and we have moles. So we've got to go from moles back to molarity. So taking back to this equation where we had molarity equals moles over liters, in this case we do the amount of moles of hydrochloric acid over the liters, which we had converted up here, in order to get the molarity, which is 0.114296, which is the answer to our question. Lastly, I just wanted to point out a couple of common mistakes that happen along the way. So you need to be careful whenever you're originally balancing your equation, because a lot of times numbers get jumbled up and we end up with 2's here, 4's there, 7's, and it ends up screwing everything up as you go, because on this step we have to use our balanced equation. So just be careful there. And also, whenever we're converting from milliliters to liters, a lot of times whenever the original equation is given, it's in milliliters, so make sure you watch out for that. And lastly, make sure you go back and check the question, because as you saw, we solved for moles originally, and then we had to take it one step further and solve for molarity. So other than that, as long as you follow the steps, you should be able to solve the question.